Hello everyone, you are welcome to my channel. Today I'll be showing us the in-depth understanding about Linux file permission and ownership. We need to understand that by design, Linux is a multi-user operating system. In an enterprise system, there will be multiple users accessing the same system. But if any user could access and modify all files belonging to other users or system files, this will certainly be a security risk. Don't you think so? And this is why security measure in place. This ensures that a file or directory can be accessed, modified by only desired user. Which file will be accessed by user is decided or determined by two factors in Linux. And the first factors that we'll talk about today is file ownership. But I will emphasize more on file permission. Alright guys, now let's go to file ownership in Linux. You know guys, I might use the term file here, but it is applicable to directory as well. So if I'm talking about files, I'm talking about directory as well. So both files and directory, they are interwoven. Now, we need to understand that every file and directory in us, it has three kinds of owners. Three kinds of owners. The first owner is what is known as user. User is the owner of the file. You know, when you create a file, then you become the owner of that file. The ownership can be changed as well, but we mention this one later. I will explain more on this. The second owner is what is known as group. Every user is part of a certain group. We need to understand that a user belongs to a certain group. You know, a group consists of several users, and this is one way to manage user in multi-user environment. For example, let's assume you are in the dev team and you have different teams inside this dev team, you know, and you guys are accessing the same system. There should be a way to create separate group for you guys. And this way, you can manage file and security of the system effectively. It saves time because instead of manually adding permission for each user, you can simply add them to a group and change the permission for the group. Now I will show us something. And the third owner is what is known as order. Order can be considered as a big group with all the users on the system. Basically, anyone with access to the system belongs to the group. So in a nutshell, I can say user is a single user. I can say that user is a single user, while group is a collection of users. I can say user, a single user, while group is synonymous to a collection of users, and order, which is the third owner. Order could be all the users on the system. Now, so this is the three users, the three owners that we have, that a file or directory have in Linux system. Now let's move to file permission in Linux. In Linux, every file and directory in Linux has three permission for all the three kind of owner that they have. If I say three kind of owner, I mean the user, the group, and the order. Now, let's go to permission for files. Under permission for file, we have read, which means the owner can view or copy file contents. Then the second permission we have write, which means they can modify the file content. While the execute, the last permission, that means they can run the file if it is executable. Now we have permission for directory as well, which is read. That means the owner or the user can list all files and copy the file from directory. While write, it can add or delete file into directory. And execute, that means it can enter the directory. Now I will explain to us what it really means by this. Now that we are all aware about the basic terminology and the terms used in file permissions and ownership, now we can take action. You open your Linux, open your machine. I'm using Kali Linux. Open your Linux. Then you open your terminal. Open your terminal. Let us assume we create a file. Let us assume we create a file. Let's create a file. And this file, I call the name of the file. If I say touch, new file, I call it new file.txt. Now if I create this new file.txt, and for me to check the permission under it, I will need to press ls, then L, then the name of the file, new file.txt. Then I will click enter. As you can see here, you will notice that it displays this permission that is available in this file. You can see that it displays something here, this highlighted place here. And let me explain it one after the other. We can see that this first one, this first dash here, is what is known as file type. This file type. The second one here, what we have here is what is known as permissions. These are the permissions on this new file.txt. And we can see this one here. We can see this one here. This one here simply means the hard linkant that comes with file. And we can see the user owner. We can see the owner here. We can see the owner here. Then we can see the group here. The reason why it is like this is because anytime you create a file, it will create it as a user and it will create it as a group. That means both users, this user root and this root here, they have access to this file. And this is the file size. We can see that this is the modification timestamp, this timestamp, and the last one here, it is known as file name. Now we are going somewhere. We are going somewhere. Now I want to show us something here. So I will go back to this place. This is where we are laying our emphasis in this video. Now we are saying RW R here. What does this mean? What is this? Now we need to know that all these, they are known as permission. These are the permission on this file. This is the field that shows the permission set on the file. Now, to break it down, this R that we are seeing here, this first R, it simply means read. This is the read permission. And this W here, this is write permission. And we have another one again, that's X, which is execute permission. I will explain everything to us. Now, there is a way this file can be changed. And this is where we introduce a command called change modification, or we call it change mode. Change modification. We can see CH mode, which means change modification. And when we go to our man and we say change mode to read about the command, we can see that change mode, you can see that it can change the file mode bit. And if you read it downward, it's explained in details everything that we need to know about change modification. And that is what we'll be using in this lecture today. Now, we need to understand something, that for us to change file in Linux, there are two ways to use this change mode. And the first way, it is what is known as absolute mode, while the second way is what's known as symbolic mode. So this first one this video will emphasize on using absolute mode. And we need to understand that in the absolute mode, permissions are represented in numeric form, which is octa system. Octa simply means 8. In this system, each file permission is represented by a number, since it is in numeric form. And we can see that we have read, we have write, we have execute, and we have no permission. Now I will bring this up in order to explain it for us, so that we can understand it in details. So I can say she mode. So we can see it now. She mode, absolute mode. And we can see that we have R here, which means read. This is our read permission. Follow me, guys. We have W, which is our write permission. This is our write permission. And we have X here, which is our execute permission. This execute permission. And we have the last one here, dash, which means no permission. That means there is no permission on that particular file. There's no permission on it. And now let me explain it for us. For us to do it, read permission is equivalent to 4. We are going somewhere. Read permission is equivalent to 4, while write permission is equivalent to 2 in that octet. In the octet system, it's equivalent to 2, and X permission is equivalent to 1. And if it is no permission is equivalent to 0. We can see 4, 2, 1, 0. Now, we are moving on. With this numeric value, you can combine them, and one another can be used to represent the entire permission set. As we can see here, we can combine all this numeric form here in order to set permission, and that is why that's where we are going next. Now, what we need to do here, I will need to explain further. So what we need to do here is, we can now start establishing it, that file permission in Linux. Since we know that 0, according to our absolute mode in octet system, will be equivalent to no permission. That's no permission. This no permission. 1 will be execute permission. This is X. 2, our 2 in octet. 2 in octet will be write permission. It will be write permission. That's write permission. Then we have 3. What do you think 3 will be? Since we didn't have it there, what do you think 3 will be? I told us that time that we can combine this numeric form. We can combine them together in order to set permission. 3 will be 2. It will be 2 plus 1. 3 will be 2 plus 1. And what does that mean? That means we can start combining them now. We can combine it. And how do we combine it? 2, as you can see here, 2 is W, that is right. While the 1 is X. That means we can combine it like this. We are going somewhere, guys. And we have 4. We have 4 here. 4 in octant system is equivalent to read. As you can see here, it's equivalent to read. That this one will give us read permission. Read permission. And we have 5 now. 5. What do we do again when we get to 5? 5 will be 4 plus 1. We combine 4 and 1. And in our octant, what is 4? 4 is R. That is read permission. 4 is read permission. Why the 1? The 1 is X. So it will be R and X. So we can say R and X here. The next one is 6. And what can we combine in 6? In 6, we can combine 4 plus 2 in order to get our 6. 4 plus 2, that means we'll be having R here. We'll be having R and W to get the 2. That is read and write. Now, the last one, we can see what can we combine in last one. Who can guess it? Alright, if you're not able to guess it, let me show us. We can combine 4 plus 2 plus 1 to get the last, to read that octant. We can combine this to read the last octant, to read the octant, which will be R, W, and X. In order to get to complete the octant. I hope you can understand it. That whenever you are counting, if it is octant, in programming, we'll start counting from 0. So now we've achieved our octant now. 0, 1, 2, 3, 4, 5, 6, 7. And this is how we itemize the permission in Linux. Now, let's go back to our machine. Let me open up my machine once again so that we can try what we have in our table. Let's open up our machine. Now, let's try it now. Let's assume that the file that we created the other time, let's put C mode. Let's assume we say C mode, new file.txt. So we have it here. All right. Okay, we can say ls. So we can say ls and this. So as we can see here, we have our permission here. Now, let's do something now. So what about if I say shmode? If I say shmode, and I want to combine some numbers in our octant here. What we have here, I want to combine some of them. Now, if I say shmode 764 new file. If I say new file.txt. Now, who can guess? Can you guess the file permission in number on new file.txt? In this our example. Can you guess it? All right. Now, let's check it now. Let's check it out. What we have here. We can see that what we have here is RWX, R. And this is why it is like this. We can know that the first 3, this first 3 here, this first highlighted 3, it belongs to the user. Why this second part, it belongs to the group. Why this one, it belongs to the third owner, which is the other. We need to understand that. As you can see, if you now combine, if you compare it with what we have here, we can see that when we say 764 here, we have 7 here, which is RWX, and that is why we are having this. We can see the 6. 6 is RW. We can see that RW is on group now. It's on the group. And the third owner here, we give it 4. And 4 is R. We can see that we have R here. And that is why we are getting this permission set in our case. Are we getting it now? Can you guess this one again? Can I say chmod 777 new file .txt? Who can guess this? What do we have here? As you can see here, this one, that means we've given it the full permission according to our table here. We can see everything here. The first 7 we give the first owner, which is the user, RWX. That is read, write, and execute. The second 7 we give group the full permission, the same RWX that we have here. And the third 7, the last 7, it will give the last owner, which is order, the full permission as well. So if I check it now, then we have it. You can see that we have it now. We have the full permission here. This is how we work with file permission in Linux using absolute mode. Like I said, the absolute mode is the numerical representation of permission sets in Linux. So thank you guys. Subscribe, like, and comment. See you next time. Thank you for watching.